Title is the high total suspended solid removals for coal mine waters using the electrocoagulation. So first of all, I want to tell you a story about the coal mine water in Indonesia. As you can see in that picture, the coal mine water in Indonesia can contain the high total suspended solid. And then the majority of mining in Indonesia using open pit mining method, which is the stripping the topsoil and in the open pit ground, for looking the mining materials. So the coal mine water in Indonesia can reach up to 10,000 milligrams per liter. So removing it becoming problems due to the large amount of the chemical usage, like the alum and like the ferric chloride and etc., especially in the large catchment areas and tropical countries like in Indonesia, which is high intensity of rainfall up to 3 meters per year. So this research aimed to implement the electrocoagulation technique as a potential active treatment to solve the high total suspended solid in actual mine waters. So this is my method. I use the acrylic reactors, 14 by 10 by 20 centimeters, and in 1 liter batch operation. So I use the actual mining samples in one of the settling pond in Indonesia, in East Kalimantan. And for the electrode, I use the 8 aluminum electrodes, 16 by 8 by 0.2 centimeters, and 1.5 centimeter distance, and the effective area is 0.024 square meters. And the variables, I use the tree retention time and the tree current. So the data analysis that I conduct in 9 experiments, but I do it multiply, so conduct in 18 experiments. And the supernatant taken at the same depth of 30 centimeters from the surface water after 60 minutes of settling time. And the measurement in this paper only in pH and total suspended solid. Yes, you can see in that tables, this is my samples, this is the actual mine water in Indonesia. For the total suspended solid can reach up to 5,400 milligrams per liter. So we need to treat more than 19% treatment of total suspended solid to facing the high total suspended solid in there. So we can meet the quality standards by the governments of the Republic of Indonesia. It says that 300 milligrams per liter. So we need to up to more than 19%. So this is the result for my study. This is the pH parameters. So the pH of the treated water increased. The increase of the pH waters due to the presence of the hydroxide ions there and release from the cathode. And the increase of the pH directly proportional to the increase of the current and the detention time that given in the system. So based on that phenomenon, it can be concluded that the electrocoagulation have a potential to raise the pH in the solution and increase the pH adjusters using chemicals. So next, for the total suspended solid, in the 2 ampere variation and the 15-minute detention time resulting the highest percentage of the total suspended removals up to 99.58% from the initial concentration 5,400 milligrams per liter to the 22.84 milligrams per liter. But as you can see, only the smallest variation, 0.5 ampere, and the 15 minutes of detention time that didn't meet the quality standards from the water regulation that held by the government of Indonesia. Sorry. Okay. Next, for the total suspended solid. So you can see there are increase in the total suspended solid over there. It's possibly due to the bubble production on there. So the bubbles in the electrolyte solution in the reactors steer the solution, and then steer the solution upward through the upward momentum. A proper amount of bubbles can increase the contact between the coagulant and the pollutant particles, but the flow cannot develop when the bubbles is too much and too rapid. So the particles cannot agglomerate if the bubbles keeps rapid. So this operation at low detention time and the low current operation at low currents and a short period of time produce relatively low bubbles, cause the gentle agitation there, and then it all allows flocculation to occur properly. So this research in line with the whole et al. And when current density increase, the bubble increase. So the upward momentum movement accelerates. So this condition will change the mixing there, and where the shear force from the mixing can break the flock, thereby reducing the removal effectiveness. As you can see in that figure on the right figures, this is my highest variation, 2 ampere at 45 minutes. And then if you can see in that pictures, there are we found a few flooding flock in there that indicating the bubbles break the flock. So the solution, if you can see that pictures, more dark than is that of the others one. So from my explanation above, the electrocoagulation proved able to solve the high total suspended solid removal. For high total solid. But this study is conducted in a small volume, just 1 liter batch operation. The actual mining coal water discharge in Indonesia can reach up to 3 meter cubic per second, 3,000 liters per second. Yeah, from this amount, it's most impossible if the electrocoagulation conduct with the batch operation. So another study limitation. So I only looked at the results of the electrocoagulation and not compare with the existing chemical coagulation. So I cannot understand the operational cost in the existing and the electrocoagulation operational cost. So we need a further study with more variables to assess the factors that could impact the electrocoagulation. But from the limitation of my studies, this is my research position. Like in this morning keynote speakers, she talked about the skills. So my research is in micro scale, but we have the spirit to continue this research more comprehensive to learn about the electrocoagulation in the mesoscale, in the continuous flow, in the larger volume. And finally, we have the spirit to implement the electrocoagulation in the field scale, in the channels between the detention pond and the sediment pond, with arrangement of the electrode that can promote the natural mixing in that. So imagine if the electrocoagulation was powered by solar panel, so the electrocoagulation electricity can run independently. And so for the conclusion, the optimum variation on the highest TSS removal is 2 ampere with the detention time of 15 minutes, can reach up to 99.58% from the initial concentration 5,400 milligrams per liter to 22.86 milligrams per liter. So the magnitude of the electric current and the detention time determine the amount of the coagulant that produced the coagulant produced in the solution from the electrode. An optimum combination required to achieve the highest TSS removal, total suspended removal. So, as like I said before, the current and detention time lower than the optimum condition cannot eliminate the total suspended solid due to the lack of the coagulant produced from the electrode. It's not sufficient to remove the high total suspended solid in the solution. But in comparison, if we increase the detention time and the longer and the larger current, it can produce bubbles rapidly, so can break the flock and reducing the pollutant removal effectiveness. So that's all from me. If you want to ask this delete slowly so I can understand what you say. Thank you.